A very good morning to one and all, dear ninth standard students. Today, 24th November, Tuesday, and this is your sir Sajid from St. Lawrence High School, Rani. So, dear children, in the previous class, as we were discussing about why objects float on or sink when placed on a surface of water, as we have discussed in one of the activity in which, as you can see here, when in a beaker a cork, as you can see in the picture here, a cork floats wherein the nail sinks. So, what's the reason behind it? Let's try to understand that. And as we have discussed in the activity, that one of the activity in previous class wherein a bottle um, which is floats on a surface of water wherein a small coin sinks in the water. The reason behind, as we have discussed, that when some objects are immersed in the water applies a force on those objects. When that force is more than the gravitational force, then the objects floats. And when um, the force applied when an object, water, is less than the gravitation force, then the object sinks. So, as you can see in the picture here, that's the reason the cork floats, wherein a small nail sinks in the water. Dear children, there are so many day-to-day life examples through which we can able to understand that why all this is going to be happen. For example, a ice cube or a block of an ice which weighs around hundreds of kgs. So when you throw that ice block in the water, the block starts floating, wherein a small nail or a small coin, or you may take just a 1 rupee coin that if you throw in the water, it easily sinks down. So this is the reason. So further, we can able to discuss through another activity which is 10.6, which is given in a textbook. As you can see here, children, take a beaker filled with the water, take a piece of cork and a nail of equal mass, place them on a surface of water, observe what happens. So what happens? The cork floats while the nail sinks. You know that. This happens because of the difference in their densities. So what do you mean by the density? So density, remember children, density always shows that the density D, right? I am going to write here density D is equal to mass per unit volume, right? Mass by volume is called the density. Got it? This is called a density, mass by unit volume. Sorry. The density of a substance is defined as the mass per unit volume, right? The density of cork is less than that of the density of water, right? This means that the upthrust of water um, upthrust of water on the cork greater than the weight of the cork. So density is the main thing that is which makes the objects floats or sinks, right? So suppose if you take a cork, or if you take some wood piece, or a block of an ice, so all those things are the density of these things are lesser than that of a water, right? So that's the reason the objects floats. So when you take a iron nail or any coin or any stone or any some heavy material, with when you small piece also it gets sinks because the density of those materials are less more than that of water. So main reason is, so if you may get a small question, that is why objects floats on the surface, or you can get a small application type examples, that is why a cork floats on the water wherein a small pin sinks. So the reason behind is the cork has a less density than the water, wherein the nail has a more density than the water. If the density is more, then obviously the object sinks, and if the density is less, the object flows. This means that the upthrust of water on the iron nail is less than the weight of the nail, so it sinks, right? So therefore object density less than that of liquid floats on a water. If the density of see, I'm talking about irrespective of the mass, and weight, the density here, the density matters. If the density is less than that of water, then it floats. If the density is more than that of water, then it sinks, right? So these questions, for example, therefore objects of density less than that of liquid floats on the liquid, the object density greater than that of liquid sinks in the liquid. Okay, so that's the reason. So next question, we can say that why it is difficult to hold a school bag having a strap made of thin strong string. Okay, so it is also only because of the density. These things we will discuss it later. So what do you mean by the buoyancy force? We have discussed in previous class. Where does an object floats or sinks when placed in the surface of water? So because of the density. So next very important thing, you may get it for the 2 marks in the examination, and this is nothing but Archimedes principle. So Archimedes was the scientist who had given some applications that we use in many places, wherein in construction of big naval ships and other things, we still use the Archimedes principle. So let's try to learn with a small activity. So in this activity, you can see here, children take a piece of a stone and tie it in one end of the rubber string or a spring balance, as you can see in the picture here. So next, suspend the stone by holding the balance or string as shown in the figure. Note the elongation of the string of the reading on the spring balance due to the weight of the stone. Now slowly dip the stone in the water in container as shown in the figure. As you can see here in the picture, you can able to understand very clearly. So you can see here, just take one stone. This activity you can do it at home very safely. That is, take one stone and just tie a string to the stone, and then take a beaker, right, and just fill a water with the beaker, and then immerse that stone inside the water, and you can connect the spring also here at the end, so that the elongation of the string we can able to see that. So look at the spring is that shape. So elongation means when the more weight is applied on that, the elongation will be more, and when less weight is applied on that, the elongation is less, isn't it? This is a common thing. So wherein you can observe that the elongation of the rubber string due to the weight of the piece of the stone subtended from in air, the elongation of decreases as the stone immerses in the water. It is obviously, as we have discussed in previous classes also, that is, it is very easier to lift a stone inside the water, wherein it is difficult to lift the stone outside the water, right? So it is only because of the force which is applied, thrust applied by the water. So suppose before immersing the, suppose you can see here in the picture, I just try to draw it. Look at here. So suppose there's a beaker which consists of water in it. Okay, imagine just water in it, and wherein when you suspend a you know a small piece of stone which is tied with the thread, and before suspending it, you can see that the elongation of the, suppose if you connect a spring here, right, elongation spring is more when it is in the air. So when it is immersed in the water, due to the water upthrust, the elongation will be little, going to be little less, right? So observe what happens when the elongation of the string or the reading of the balance. So you know that we can say now very easily that the elongation is more when the stone is at the in air. So elongation is less when stone is immersed in the water. Okay, the reason behind, as we have discussed just now, due to the water upthrust, right? Due to the water upthrust, the elongation is less when the stone is immersed in the water. And you can see that you will find that the elongation of the string of the reading of the balance decreases as the stone is gradually lowered in the water, right? When stone is immersed in the water, so elongation is little less. So why elongation is less? Because of the upthrust of water. So however, no further change is observed when the some stone gets fully immersed in the water. What do you infer from this? From these decrease in the extension of string of the reading of the spring balance. So it does mean that what do you infer? So what we have learned from this? We have learned that so because of the water upthrust. So when stone is immersed in the water, so elongation becomes little less, right? So we know that elongation produced in the string or the spring balance is due to the weight of the stone, isn't it? Elongation is produced due to the weight of stone. So something, suppose if you take a string or a string, and then if you tie a stone or something on the end of that, so elongation is it is get elongated. So it is elongated because the force is applied on the other end of the spring, right? So since the extension decreases once the stone is lowered in the water, it means that some force acts on the stone in upward direction. So as we have discussed in previous classes also, that is because only because of the water force which is applied on the string. As a result, the net force on the string decreases, hence the elongation also decreases, as we have discussed earlier, right? So this upward force exerted by the water is known as force of buoyancy, right? So this upward force which is known as force of buoyancy, right? Force of buoyancy. So this we call it as force of buoyancy, right? So next, what is the magnitude of the buoyant force experienced by a body? Buoyant force is nothing, buoyancy is nothing but a buoyant force, right? So what is the magnitude of the buoyant force of to a body is the same in all the fluids for given a body. Do all the bodies in the given fluids experience the same buoyant force? The answer of this question is, let's try to understand that. So contained in the Archimedes principle. So Archimedes principle states that, right? It says that, so is it same for all the liquids, whether it's a water or whether it's some sort of oil? So all the liquids, all the fluids, it will be same. Let's try to understand through the Archimedes principle. So Archimedes principle, dear children, which is very important for a 2 mark. We know that, isn't it? Archimedes principle, right? Which is very important. We say that when a body is immersed fully or partially, right? When a body is immersed fully or partially in the liquids, right? Remember that, children. Archimedes principle is comes around under the liquids or fluids. So when a body is immersed fully or partially in the fluids, it experiences an upward force that is equal to the weight of the fluid displaces by it, right? So as you can see through understand through a picture here from the last page, as you can see here, so when the stone is immersed, right, when the stone is immersed in the water, so you know that it displaces the water, right? We can understand it through a small example. And we have all learned a crow story, right? When you're in a childhood, so wherein a thirsty crow wants to drink the water, when it finds the pot, the water is too deep, and what the crow does, so it will take the pebbles from around it, and then it throws in the pot, and when water level comes out, okay, come up, the crow drinks the water and flows away, right? So this is the one small story we have learnt in our childhood. So that same story is applied in the Archimedes principle also, as you can see here. So when the stone is immersed in the water, right, the same amount of the water which get displaces, you know that it displaces, right, displaces from the beaker. Through this, what we can able to infer, what we can able to understand that, so Archimedes principle says the same thing in the law, that is when a body is immersed. See what Archimedes principle says. So when a body is immersed fully or partially in a fluids, right, it experiences an upward force that is equal to the weight of the fluid displaced by it. So Archimedes principle says that when some objects are immersed in the fluids or water, so it is equal to the upward force such that, so the water or fluids get displaced means displaced by it, right? Now you can explain why a further decrease in the elongation of strong string was not observed in the activity 10.7 when immersed in the water, right? So when immersed in the water, so when the stone is immersed in the water, the elongation of string, you cannot able to see the elongation of string. So the reason behind the string is not get elongated, so it displaces the water from it, right, through the upward force. So as stone was fully immersed in the water, right? So Archimedes principle has mainly many of application, as I told you. Remember children, this is very important, that is Archimedes principle, which is for a 2 mark. You have to sum up all that. So next, Archimedes principle has many applications. Remember that application is nothing but its form of uses, and some information about the Archimedes is given. Kindly go through it afterwards. And listen here, the Archimedes principle has many applications, wherein applications nothing but uses, right? As you can see in the science, applications, uses. In normal English we can say the uses, but in science we can say applications. So what are the Archimedes principle, which has many applications? So it is used designing ships and submarines, isn't it? It is used to designing the ships and submarines. So based on the Archimedes principle, the ships and submarines are designed. So what are the ships? You might have observed that in the in the sea, in the harbor, you might have observed that a lot of big ships were constructed, and simply they cannot construct the ships, isn't it? For example, if you make a paper ship, and then it floats on the water. If you add some apply some more, put some weights on it, so after some time that is going to sink, right? But here you might have observed that in big ships it is just like a small village. So whole big ships and every multi-story buildings you can able to see in that. So all this will be made with the help of the Archimedes principle. So Archimedes principle, which is says that, remember that when an object is immersed fully or partially in the liquids, right? Liquids, whether it's a water, whether it's a other liquid which flows, right? So Archimedes principle has many applications, means many uses. So it is used in the designing ships and submarines. And lactometers. Lactometer is a device which we use to check the purity of water, right? It is works on the density, right? It is works on the density. Lactometer is a device. It's just like a device like a meter, like a thermometer. So which is going to be which will be used to check the purity of water. So that is also works on the principle of Archimedes principle, which are used to determine the purity of sample of milk. And hydrometer used for determining the density of liquids are based on this principle, right? So here we can get 2 mark question again. That is, what are the 2 mark question again? So what are the applications of the Archimedes principle, right? Archimedes principle. So application of the Archimedes principle are nothing but Archimedes principle is used in designing the ships, designing the submarines, and it is used in the lactometer. So what is the lactometer? Lactometer is a device which through which we can measure the purity of milk, right? Density of milk. And also it is used in hydrometers. Hydrometer is used for determining the density of liquids, right? So hydrometer, remember that lactometer is a particular meter which is used to determine the purity of milk. So hydrometer is a device which determines the density, mass per unit of liquids, right? Especially liquids. And Archimedes principle is also used, means day-to-day life application of the Archimedes principle is it is used in the manufacture of big ships or submarines, right? So right. Next, the last concept that we are going to discuss today is relative density. So, what is relative density? As the name indicates, relative density, it gets related, right? So, as you know that the density of substance defined as a mass of per unit volume. The unit of a density is kilogram per meter or kilogram per meter cube. So, we can define it by the kg per meter cube. As you can see that kg m whole raised to -3. So minus 3 kg divided by m cube is nothing but when m cube comes up, you know that it becomes minus. So it is called as, it should be written as kg m raised to -3, but should be read as, so kilogram per meter cube. The density of a given substance under specified conditions remains the same. Therefore, the density of substance is one of its characteristic property. Right. So, substance, the density is one of the characteristic property, isn't it? Because as far as fluids are concerned, so density is nothing but so mass per unit volume. So it is different for different substances. Obviously it is different from different substances. For example, if you take in water, so density is different. If you take in some coconut oil or some edible oil, so all the fluids have different densities. For example, the density of gold is 19300, right, 19300 kilogram per meter cube, the density of a gold. This is for even not only for the liquids, even all the metals have the density, right? So the gold density is a 19300 kilogram meter cube, while that of a water is 1000 kilogram per meter cube. So as you can see here, one important thing I'll tell you, children, remember that. As you can see, I'm going to mark it here. You can see that the density of water, if we talk about the water, the density of water is a 1000 kg meter cube, right? If density is more than that of, means suppose it is a 1001, 1002 or anything, okay, if the density is more than the 1000, so obviously the the object is going to sink in the water, because density is more. If the density is less, for example, the water density is 1000 kg per meter cube, if the density is less than that, means suppose if the density is 900, if the density is 800, if density is 700, so whatever it is, so if it is less than that of 1000, so we can say that the object is going to sink, right, in the water. So remember that density is few things we have discussed just now. Just now we have discussed that gold density is 19300 kilogram per meter cube, so it is more than 9300 from 1000, right? So obviously the gold is going to sink in the water. If you cut a small piece, suppose 1 gram of gold, if you cut and if you throw in the water, so it's obviously going to sink. So next, why? What's the reason? Because water density is 1000 kilogram per meter cube. This also we have to remember, because you can get this question in the MCQs. In the MCQs you may get these questions, right? So remember that the water density is 1000 kg per meter cube. So since the reason, if the density is more than that, it is not, it is water density is 1000, got it? So whatever the object, if the density is more than that, so the object is going to sink in the water, right? If the density is less than that of water, so that object is going to float on that. So density of given sample is discussed can be helped to determine the purity, right? It is often convenient to express density of a substance in a comparison with that of water. The relative density of substance is the ratio of the density of that water. So as far as density is concerned, density of a relative density is concerned, we relate the density with the help of a density of the water. Remember that. As you can see in the I'm going to mark here, as you can see that relative density. So for our convenient, got it children, for our convenient, what we are going to do, for our convenient, we take the density of a substance that we relate with the density of water. And just now we have discussed the density of water is nothing but a 1000 kilogram per meter cube, kg m raised to minus 3, right? So relative density, that density is nothing but a relative density, means for our convenience, what we do, the density of the water we relate with the density of a density of a substance we relate with the density of water. As we have just now discussed, if the density is more than that of water, right, so object sinks. If the density is less than that of water, then the object floats, right? Since the relative density ratio is similar quantities, it has no unit. So since we are just relating it, isn't it, we are just relating it to the other substances with the water, so it has no unit. So we are not given any unit to this. The reason behind we are not given any sort of unit to it means density of a substance we relate with the density of a water. So since it is the correlation, so these are we, for our convenience, we just relate it to the density of water, that is 1000 kg per meter cube. So that's the reason we are not going to give any sort of a unit to it. So next we are going to see a small example and just try to conclude this chapter. As you can see in the example here, relative density of silver is 10.8, right? So just now we relate it to the water, right? 10.8. The density of water is 10 raised to 3 kg per meter cube. Means 1000 means nothing but a 10 raised to 3. So remember that in short method 10 raised to 3 means, so in front of 1 there's 3 zeros, right? Right. So here 10 raised to 3 kg per meter cube. You know that. You can say that 10 raised to 3 kg per meter cube, as you can say that 1000 kg per meter cube. What is the density of the silver in SI units? So SI units, how can we write the density of silver? We know that formula. Relative density is nothing but a density of a substance divided by density of a water. So this is the formula, right? So relative formula, that is this is the formula. We can say that density of a substance, any substance, here silver is given, so we take a silver. If it has gold would have been given, so we would have taken gold, right? So here you can see that density of a silver divided by density of water. So density of silver is nothing but relative density of silver into density of water. If we cross multiply it, right? If we cross multiply it, as you can see, I hope you understand that. So the formula is density of silver divided by density of water. So we need density of silver, right? Density of silver. So if we take a density of silver, we can say that it is cross multiplied by density of silver into density of water. So in that case, it is nothing but a 10.8 into just we are going to multiply it, 10.8 into 10 raised to 3 kg per meter cube, right? So children, in this chapter, I hope you understand that in this chapter we are going to we have discussed so many things. In that the law of gravitation states that the force of attraction between any two objects. About the gravitation we have discussed the Newton's universal law of gravitation, right? And which says that the gravitation is nothing but a product of their masses and directly proportional to and inversely proportional to square of distance between them. And then we have discussed the gravitation of weak force unless large masses are involved, right? So we have discussed in the previous classes, that is more the mass, more the gravity, as we have discussed with the example of our earth and moon, natural satellite, and we have discussed with the sun and other planets evolves around the sun. So all the 8 planets and other celestial bodies, so it is only because of intense gravitation force. Why the gravitation force? Because the huge size, the huge mass of a sun. Force of gravitation due to the earth is called gravity, right? The force of gravity decreases with the altitude. It is varies with the surface of the earth, that we have discussed. The weight of an body is the force with which the earth is attracts us, right? The weight is, we have discussed about mass and weight, isn't it? So mass is wherever you take an object, where it's a surface of earth, it's a surface of moon, the mass will remain same, but weight going to be changes according to the gravitation force, right? For example, on the earth the gravity is more, so the object weighs more. If you take that object, same object, on the surface of moon, the gravity is less, so that object weighs less, right? So the weight is equal to the product of mass and acceleration, isn't it? Acceleration due to gravity, right? We have discussed with the formula, and we have done few problems also. All the objects experience a force of buoyancy, as we know that discussed in the previous class. And the objects having density less than that of liquid in which they are immersed float on the surface of liquid. That's the reason. And if the density of the object is more than that of density of liquid in which immersed, it is going to be sink in the water. So we have taken the relative density also, just now we discussed. So as far as relative density is concerned, we relate the density of a other materials with the density of a water. So relative density of water we measure with 1000 kg per meter cube. If it is more than that, the object is going to sink in the water. If it is less than that, the object is going to floats on a water. So these all things we have discussed in these in previous classes. Through this we can conclude the chapter gravitation. Children, later on, if possible, I am going to send the PDF of this exercise part and other questions. So kindly write neatly in your notes. So first you are going to write the textbook questions, then you write the exercise part questions, and after that you are going to write some additional questions which are related to the gravitation. So write neatly in your notes and study well. And this coming Saturday, so Tuesday, so coming Saturday, kindly show me the notes, okay, on an open day. So from tomorrow, next class we are going to start with a new chapter. So till then, take care and bye bye.